네, 여러분 지금 귀빈 여러분들께서 입장하고 계십니다. 큰 박수로 환영해 주시면 고맙겠습니다. 네, 여러분 안녕하십니까? 스트롱코리아 창조포럼 2016에 오신 여러분들을 환영합니다. 저는 오늘 진행을 맡은 아나운서 송상은입니다. 반갑습니다. 네, 고맙습니다. 오늘 우선 정말 바쁘신 와중에도 이 자리 더욱더 빛내주시기 위해서 이 자리에 함께해 주신 주요 내빈 여러분 정말 감사드리고요. 그리고 이른 아침부터 이 강당을 가득 메워주신 여러분들 환영하고 또 깊은 감사의 말씀 먼저 드리겠습니다. 스트롱코리아 창조포럼은 매해 저희가 개최하고 있습니다. 사회 각 분야의 최고의 권위자들, 리더들을 저희가 모시고요. 그런 분들이 참석하셔서 국가 성장 동력과 과학기술 혁신, 그리고 산업 경쟁력, 기업 생산성 강화 방안 등에 대한 해법을 제시해 오고 계십니다. 특히 올해는 여기 보시는 대로 주제가 이 과학기술의 미래, 기초 연구에 달렸다를 주제로 저희가 자리를 마련했는데요. 이런 주제인 만큼 참가자 여러분들 모두에게 유익한 시간이 되시길 기대해 보겠습니다. 자, 그럼 지금부터 스트롱코리아 창조포럼 2016의 개회식을 시작하겠습니다. 개회식 첫 번째 순서로 본 포럼의 주최기관인 한국경제신문 김기용 사장님의 개회사가 있겠습니다. 여러분 큰 박수로 맞이해 주시기 바랍니다.
여러분 대단히 반갑고 고맙습니다. 먼저 한국경제신문 김기용입니다. 먼저 이번 행사를 위해 여러모로 애써주신 한교안 국무총리님, 홍남기 미래창조과학부 제1차관님, 김성원 한국과학창의재단 이사장님, 정민건 한국연구재단 이사장님, 김두철 기조강연 원장님께 감사 인사를 올립니다. 또 바쁘신 와중에도 정말 어려운 걸음 해주신 신용현 국민의당 국회의원님, 박병은 한국경영자총연합회 회장님, 박상구 금호아시아나그룹 회장님, 김도현 포스텍 총장님, 이병건 한국과학기술연구원 원장님 등 많은 분들께도 깊은 감사의 마음을 전합니다. 일일이 소개드리지 못하지만은 이 자리를 빛내주신 여러 경제계, 학계, 리더 여러분들께도 고마움을 전합니다. 아시다시피 저희 한국경제신문이 스트롱코리아 캠페인을 시작한 것은 지난 2002년이었습니다. 땅덩어리도 작고 자원도 부족한 대한민국이 글로벌 경쟁에서 살아남을 수 있는 길은 기술밖에 없는 만큼 우리의 미래를 책임질 과학기술 인력을 대거 양성하자는 취지였습니다. 이런 환경의 제안은 각계의 공감과 참여를 이끌어냈고 덕분에 스트롱코리아는 출범 15년 만에 과학기술 분야에서 가장 권위 있는 포럼 중 하나로 성장했습니다. 실제 스트롱코리아를 통해 과학기술계 종사자들이 제안하신 내용 중 상당 부분이 정부 정책에 반영되었습니다. 2004년 제정된 국가 과학기술 경쟁력 강화를 위한 이공계 특별법과 지난해 기초과학교육을 강화하는 방향으로 제정된 제3차 과학기술인재 육성 지원 기본 계획이 아마도 그 대표적인 사례일 것입니다. 또한 디지털 시대를 맞아 소프트웨어 교육 중요성을 강조해온 스트롱코리아 시리즈는 정부의 소프트웨어 중심 사회 선언으로 이어졌을 뿐만 아니라 전국적으로 불고 있는 코딩 교육의 확산에도 일조를 했습니다. 이렇게 지난 15년간 과학기술계에 다양한 하도를 던졌던 스트롱코리아가 올해 내건 주제는 과학기술 미래 기초 연구에 달렸다입니다. 추락하고 있는 대한민국의 산업 경쟁력을 다시 끌어올리기 위해 지금 이 시점에서 가장 필요한 것이 바로 기초 연구 강화라고 생각했기 때문입니다. 잘 아시다시피 그동안 패스트 팔로우 전략으로 성장해온 대한민국은 이제 거의 모든 분야에서 중국이라는 새로운 패스트 팔로우에 따라잡히고 있는 실정입니다. 이제 우리가 살 길은 지도에 없는 새로운 길을 개척하는 퍼스트 무비로 변신하는 방법밖에 없습니다. 퍼스트 무버가 되려면 과학기술에 대한 기초 체력이 단단해야 합니다. 세상을 바꿀 아이디어와 기존 기술을 압도하는 신기술은 어느 날 갑자기 하늘에서 뚝 떨어지는 것은 아닙니다. 오랜 기간 공들여 차곡차곡 기본기를 쌓은 국가와 조직만이 그 달콤함을 누릴 수 있을 것입니다. 오늘 프로그램은 국내 과학기술 분야의 최고 싱크탱크인 한국과학창의재단, 한국연구재단, 그리고 기초과학연구원 등과 머리를 맞대고 마련했습니다. 우선 전 세계적으로 코딩 열풍을 불러일으키신 자크 심저 코드카데미 창립자께서 디지털 시대 인재와 소프트웨어를 주제로 기조강연을 해 주십니다. 또한 인공지능과 딥러닝 분야의 대가인 프라딥 두베이 인텔 병렬 컴퓨팅 랩 소장과 메이커스 문화 열풍을 통해 1인 제조 시대를 선도해가고 있는 짐 뉴턴 테크숍 회장 겸 창업자께서 나오셔서 최신 과학기술 흐름과 동향을 짚어볼 것입니다. 오후에는 한국과학기술 미래 50년 기초연구 추진 전략에 대해 스티브 그레닉 기초과학연구원 첨단 연성물질연구단장, 김성근 서울대 자연과학대 학장, 문길주 과학기술연합대학원대 총장께서 주제 발표와 토론을 벌여주십니다. 아무쪼록 오늘 참석하신 여러분들께서 향후 몸담고 계신 조직의 R&D 전략이나 혁신 전략을 짜실 때 오늘 포럼이 도움이 되기를 희망합니다. 저희는 이번 포럼에서 각계 전문가분들이 내놓으시는 제안을 단순히 전달하는데 그치지 않고 각 기업의 R&D 전략은 물론 국가 R&D 정책에도 반영될 수 있도록 힘을 다해 돕겠습니다. 다시 한번 이 자리를 빛내주신 모든 분들께 감사 인사를 올립니다. 여러분과 여러분의 가정과 여러분들이 하시는 일에 건강과 행운이 함께 하시기를 진심으로 기원드립니다. 대단히 고맙습니다.
네, 한국경제신문 김기웅 사장님의 인사 말씀 먼저 함께 하셨습니다. 이제는 정말 이 자리를 자부심과 또 사명감을 동시에 갖고 임해야 되지 않을까 싶은데요. 그런 만큼 오늘 이 자리를 통해서 많은 해안들을 엿볼 수 있었으면 좋겠습니다. 자, 다음은 황교안 국무총리님의 축사가 있겠습니다. 여러분, 총리님을 큰 박수로 맞이해 주시기 바랍니다.
(80년대) 말에 PC 통신이 처음 나왔을 때 제가 잘 알지도 못하면서 캐텔에 들어가서 PC 통신을 사용하면서 아주 지적인 희열을 느꼈던 때가 있었는데 그 캐텔이 하이텔로 발전하고 쭉 이렇게 해서 오늘 한국경제에서 오늘 이런 그 큰 창조포럼까지 이어져 오시는 과정을 이렇게 보면서 감회가 새롭고, 이 과정을 이끌어 주시는 우리 김기웅 사장님께 다시 한번 감사의 말씀을 드립니다. 또 이 자리에 뵈니까 제가 좀 오늘 조금 일찍 와서 여러분을 좀 뵈보니까 정말 우리 과학계의 거장들이 다 모이셨고, 또 우리 결국 과거도 끌어오셨지만 미래도 끌어가실 이런 분들이 많이 계셔서 인사를 나눌 수 있게 된 것을 아주 기쁘게 생각하면서 이 자리에 들어왔습니다. 존경하는 국민 여러분, 그리고 과학기술인 여러분, 스트롱코리아 창조포럼의 개최를 진심으로 축하드립니다. 과학기술 발전을 위해서 다양한 캠페인을 펼치고 있는 한국경제신문 우리 김기웅 사장님을 비롯한 관계자 여러분께 감사의 말씀을 드립니다. 이번 포럼에서 발표와 토론에 참여하는 과학기술 분야 석학과 전문가 그리고 기업인 여러분들께도 감사를 드립니다. 올해는 정부가 1996년 처음으로 키스트를 설립하고 또 그 이듬해 과학기술처를 출범시키면서 과학기술진흥에 나선 지 50년이 되는 의미 있는 해입니다. 우리나라는 그동안에 과학기술 진흥을 밑거름으로 산업화의 기적을 이룩할 수 있었다고 생각하고, 여기에 과학기술인 여러분들의 많은 기여가 있었기 때문에 이 부분에 관한 감사와 노고에 대한 치하의 말씀을 드립니다. 과학기술인 여러분, 여러분이 이번 포럼에서 우리나라 기초과학 발전 방향과 전략을 모색하는 것은 이 시점에서 그 의미가 매우 크다고 생각합니다. 지금 세계가 지식 기반 사회로 빠르게 이행하고 있습니다. 그러면서 과학기술의 발전, 특히 기초연구의 중요성은 더욱 강조되고 있습니다. 기초연구는 융복합 과학기술 발전의 토대이며 그 파급 효과가 전 산업에 미친다고 할 수 있습니다. 우리가 추진하는 창조 경제를 실현하기 위한 창의적인 지식과 도전적인 아이디어는 상당 부분 기초연구에서 창출된다고 할 수 있겠습니다. 정부는 이러한 인식을 바탕으로 해서 기초연구 활성화를 위한 정책을 적극 추진하고 있습니다. 국가 R&D 시스템을 혁신해서 과거의 양적 성과 목표에서 질적 성과 중심으로 바꾸어 가고 있습니다. 지금까지의 추격형 국가 R&D 전략을 넘어서 기초연구를 핵심으로 하는 선도형 R&D로 미래 성장의 기반을 다져가고 있습니다. 정부는 민간에서 하기 어려운 한계 돌파형 기초연구와 연구인재 양성에 집중하면서 장기적인 안목에서 지원과 투자를 강화해 나가겠습니다. 연구비의 자율적인 활용도를 높일 수 있도록 네거티브 방식의 예산 집행 기준을 도입해서 우리의 연구 환경과 문화를 개선해 나갈 것입니다. 존경하는 과학기술인 여러분, 지금 우리는 글로벌 경기 침체가 지속되는 가운데 다시 한번 도약하느냐 아니면 정체하느냐의 기로에 서 있습니다. 저는 여기에 과학기술이 답이라고 생각합니다. 우리가 지금의 어려움을 극복하고 경제 재도약을 이루기 위해서는 과학기술이 선도적인 역할을 해야 합니다. 하나의 창의적인 아이디어와 혁신적인 기술이 우리의 국가 경쟁력을 강화하고 글로벌 시장의 판도를 바꿀 수도 있습니다. 우리 경제가 힘차게 도약할 수 있도록 과학기술인 여러분들이 앞장서 주시기를 바랍니다. 정부는 여러분이 더 큰 자긍심을 갖고 역량을 발휘하실 수 있도록 적극 뒷받침하겠습니다. 다시 한번 스트롱코리아 창조포럼의 개최를 축하드리고 여러분 모두의 건강을 기원합니다. 감사합니다.
네, 황교안 국무총리님의 축사 함께 하셨습니다. 오늘 정말 바쁘신 와중에도 저에게 축사 전해주시기 위해서 이 자리에 함께 하셨는데요. 소중한 말씀 대단히 고맙습니다. 자, 이것으로서 스트롱코리아 창조포럼 2016의 개회식을 모두 마치도록 하겠습니다. 저희는 잠시 무대 정리를 한 뒤에 기조연설 진행하도록 하겠습니다. 자리에서 잠시만 기다려주시기 바랍니다. 네, 그럼 지금부터 기조연설 순서 이어가겠습니다. 자, 기조연설은 앞서서 소개해드린 대로 자크심즈 코드카데미 창립자께서 디지털 시대 인재와 소프트웨어를 주제로 강연해 주시겠습니다. 자, 그럼 자크심즈님을 단상 위로 모시겠습니다. 여러분 큰 박수로 맞이해 주시면 고맙겠습니다.
Good morning. So first of all, thanks to everyone for having me here today. It's a real honor to be here to speak about science and technology in a place that's really helped to contribute to a lot of science and technology development around the world. And so when I was first asked to speak here a couple months ago, I thought a lot about what I could speak about. One of the key topics that I was asked to discuss was global education, what the students of the future could potentially look like. And then, most importantly, how we start educating the students of the future in a time when the skills that students need to learn are changing rapidly every single day. And so today, I'm going to hopefully walk everyone through a couple of different things. I'm going to start by discussing the way the education system works right now, both in Korea, the United States, and in countries around the world. After that, going to break apart what I think is wrong with that system, and perhaps why it's not living up to the standards that we've set for it, and why new and ambitious programs are needed to create an education that can help people prepare for the future. Then, I'm going to walk everyone through a few success stories of students that I'm familiar with that seem to be the archetype of the students that we might want to be educating in the future across the world. And lastly, I'll talk about how we can make sure every student that we're graduating from schools and institutions in the 21st century, and also students that are learning on their own, can help to become those same prototypical examples of the students that we want in the 21st century. So, by way of introduction, my name is Zach Sims. I started a company called Codecadeمی. At this point, we have more than 25 million students all around the world that learn science and technology skills that help them find jobs. Those skills, for the most part, are programming, which allows people to, from anywhere in the world, sit in front of their computer and create something that can be the next big global phenomenon and affect people all over the rest of the world, simply with a computer in front of them. So, in starting today, I wanted to ask a key question. What is education? I think all too often we think of education simply as something that happens in a school. We think that when a student turns 5 or 6, they start going to elementary school, they start learning from a teacher in the front of a classroom, and then they finish their education by the time they get older and by the time they graduate from college. I think it's time we challenge that notion and we start thinking of the fact that education is something that should be with us over the course of our entire lives. So that's the first thing I'm proposing here today, is that education isn't something that we think of in school from when students start until they stop when they finish college, but something that happens over the course of a lifetime. And so with that, I'm going to break apart the 3 different pillars that I think compose the way we think of education today. The first, I think, is content, which is what our students are learning. So traditionally, you've noticed I've included a picture of a stack of books in the background, because when we think of the content that our students are learning, all too often that content is contained within a book. And so the first thing that the education of the future will do is reimagine the subjects that are taught to our students all around the world. Now, those subjects don't have to be contained inside of books, and they don't have to be conveyed the same way I'm speaking to everyone right now, which is with the traditional sage on a stage model. Instead, I think we should look at how our students are learning, which is the second pillar of education, which is delivery. Again, I think in a formalized education system, you're looking at a series of lectures, oftentimes like this one, where someone stands on the front of a stage and speaks to hundreds of people in an audience in an attempt to convey information to them. With the 21st century, there are all different types of new technological innovations that we can use in order to deliver new and different types of content in innovative ways that help students learn even better than they ever could before. And so the last component of education that I'll talk about today is institutions, which is where our students are learning. Again, as I said in the beginning of the talk, I think we tie together these notions of content, what our students are learning, and delivery, how our students are learning, and we think that those two things can only take place in formalized institutions, whether that's in a school system that's powered by the government, or whether that's in a school of higher education, when actually, now that everyone has a computer easily and readily accessible, the notion of education itself has changed so that an institution like Codecademy, for instance, can educate more people from their computers around the world than you might be able to educate in a traditional brick and mortar classroom that you would find across the world. So, just to sum it all up again, I think the three things about education that we can talk about fixing in the future are the content, which is the raw material and the subject matter that students are learning. It's the delivery, which is the method that they are learning that list of topics. And lastly, the institution, which is the establishment charged with that student's education. And with the pace of technological change across the world, we're seeing each of these be reinvented on an increasingly quick scale, which means that we need new institutions that are able to adapt quickly to new types of content that need to be taught for our students to be successful, to new types of delivery that can help our students learn faster than ever before, and new institutions that help to support those pursuits in getting students where they need to be even faster. So now that we've talked about the different components of education, I think we can talk about the traditional education life cycle. And when I think about the life cycle of education, as I mentioned, it's when does a student start learning? What steps do they go through over the course of their learning process? And where, if at any point, does that learning actually end? Because if you think about consumer behavior, even in the past 20 years, we've gone from a world where reading material was only accessible when you had a book with you or a magazine or a newspaper with you, to now, reading material is available and accessible 24 hours a day in your pocket. And the same is true of education. And all too often, we think of this life cycle as the same as it's been for the past couple hundred years. So I think traditionally, everyone thinks that education starts in a formalized context in what in the US we would call K through 12, which is primary education. And so across the world, we look at the purpose of primary education as teaching students foundational literacy. Oftentimes, that's grouped into the 3 R's, reading, writing, and arithmetic. Oftentimes, those measures of success that K-12 education is held to vary across the world. When we're measuring literacy, organizations like the OECD and administer tests like PISA that look at how nations around the world train their students to perform on commonly understood standards that help to compare across countries in different regions across the world. Now, the way students are taught in K-12 education also differs from country to country, but even within individual countries as well. You have private school systems, public school systems, and methods that vary widely, whether you have schools that focus on rote memorization, where students are memorizing times tables, for instance, where they're memorizing different ways of reading, or you have schools that are more open-ended and give students the opportunity to brainstorm and think of creative solutions to problems. Now, oftentimes, the fact that these institutions are training 20 or 30 students at a time in the same classroom means that we end up with generations of students who are accustomed to what's called Swiss cheese learning, which is where this notion of one-size-fits-all education means that while some students in a class are learning at a rapid rate and others are learning at a slow rate, you have different holes in students' educations that by the time they get old enough to be able to go to college, they have gaps in their learning that are caused by the fact that one education is supposed to fit all of those people over the course of their primary education. Now, oftentimes, after a student's K-12 education, the most important thing that students can do is progress onto college and forms of higher education. So while we oftentimes look at K-12 education's effectiveness as whether or not students score well on things like the PISA test and understand literacy, arithmetic, and writing, at the same time, we also are measuring how often those institutions lead students to institutions of higher education. Because across the world, we oftentimes think that those are the gateway to a better job and a better life, which leads me to the next set of institutions, again, higher education. Now, the purpose of higher education differs in different cultures and across the world. There are traditions like the liberal arts, where students are focused on learning a broad-based set of concepts, again, focused on a general world awareness that students possess and a frame of view that helps them understand the world. But when we look at return on investment for students, oftentimes we're looking at the employment rate or the vocational outcomes that students get through higher education. Now, this is an interesting conflict that oftentimes plays itself out across the world, where on one side, people are paying for an experience. They're paying for the opportunity to understand a broad set of concepts that might not have a distinct economic payoff in their future. And on the other side, you have a lot of people that are interested in making sure that the money they have invested in higher education pays itself back over the course of their career. So oftentimes the incentives, both for students and instructors and for institutions, vary across the world, depending on the way each of those different stakeholders thinks about the purpose of that higher education. So again, when thinking of how we measure the success of students that attend schools of higher education, oftentimes we look at the percentage that are employed after a year, having 365 days after they've completed their higher education in order to progress into what we would call the real world, where someone has a job. Again, in higher education, the way that students are taught traditionally starts with something like this, where you have someone at the front of a classroom who's lecturing to hundreds, if oftentimes thousands of people that are sitting there passively listening and not deeply engaging with the material. Occasionally, in good schools, you'll have small group learning as well, where people learn together and collaboratively to reinforce the concepts that they would learn in an individual lecture. But oftentimes, these suffer from the same problems that we would ordinarily see in the K-12 learning examples that I gave, of an education that is fit for a room of hundreds of people and oftentimes leaves those people behind. Now, for some people, they're lucky enough to get access to continuing education over the course of their career. Now, this I talk about in a more loosely defined manner, because traditionally, continuing education can be offered by universities, can be offered by companies, can be offered by individuals, just ordinarily with the outcome designed for students to get better opportunities in their futures. And traditionally, these classes can be taken any time after a student graduates from an institution of higher education. So you could think of this as an accounting class, for instance, that a student takes in order to become certified, or a programming class that you take in order to get a certification from someone like a Microsoft. And again, traditionally, these are part of other institutions and taught in the same way, where when we think of education, for each of these examples, whether it's K-12, higher education, or an institute of continuing education, we're expecting students to go to a brick and mortar physical place to continue that learning, where they're learning a relatively static set of content that remains the same across all the students that are learning it. And the delivery mechanism is oftentimes designed for all of those students at the same time. So now that I've discussed how each of those three components of the educational system function, I think it's important to dissect how each of those components are working. If you look at K-12 education across the world, as I mentioned, traditional measures of success would have us look at how countries do on PISA scores and on tests that are comparable across different countries. And by most of those measures, South Korea is basically the best in the world. 68% of South Koreans aged between 25 and 34 have a college education. That's compared with the US, which at number 14 has only 46% of that demographic of students with a higher education. South Korea ranks number 1 for PISA tests in reading, math, and science, while the US has a lower than average reading, math, and science set of PISA scores. As we talked about earlier, though, one of the things that's conspicuously absent in most of this educational ranking material is ICT, or information and communication technology, where we don't necessarily see easy ways to compare a country's digital literacy with others across the world. Now, if we now look at higher education, as I mentioned, traditionally, we look at the success of higher education institutions as whether or not their graduates are employed about a year after graduation. And to me, it's pretty plain that across the world, and in South Korea and the US, these institutions are not doing what they should. In the US, about a year after graduation, 41% of college students are unemployed or underemployed with a job that doesn't grant them a salary that would befit the college degree that they studied for over time. In this country, it's 50% as well, where students are graduating with a college degree, oftentimes staying in school for an extra year in order to make sure that they can be prepared when they're ready to graduate from college. Former South Korean President Lee Myung-bak said, "Reckless university enrollment has aggravated both the private education burden and youth unemployment. It is a huge loss for the country." To me, I think this problem is not one that simply persists in our country and in this country. It's a problem that exists across the world of thinking that university enrollment is the key focus for students in order to be successful in the modern economy. So I look at our higher education institutions and I think that they're failing to provide our students with the innovative skills they need to be successful in the 21st century. They're not providing our students with jobs. They're not providing our students with the literacy they need in order to be successful, or the frame of mind that prepares them for the 21st century. And lastly, when I look at continuing education, in both this country and the US, we have institutions that hire students that are not prepared to change their understanding of what career mobility means. I think this is a really important point as well, is that in order for educational systems to change, and in order for innovation to happen, we need to change our notion of what it means to be conventionally educated, where traditionally you would see students with university degrees are the only types of students that would be able to get a job. Now, we need to change that perception so that any type of student, whether they've learned on the internet, whether they've learned in a formal institution, will be eligible for a job at the best companies that need those same skill sets for students. So, as I mentioned on this educational life cycle, there's this concept of a road where students start learning in an elementary education in K through 12. They continue that learning in higher education, but oftentimes it stops when they've obtained that first job. Students think that they've learned everything they need to learn and that they don't need to keep innovating and changing the skill sets that they have that allow them to be competitive in the 21st century. And I think we need to change that notion and make sure that learning is a lifelong pursuit for students across the world. So now that we've looked at each of those different educational systems, I want to parse apart a few more things that I think are worth solving. Again, when we look at solving these problems that I've talked about and look at each of those systems, we try to solve the problems by repeating the mistakes that we've made in the past and by thinking within the same system that we've always thought in. In the US, the president set a goal of becoming the nation with the highest proportion of 25 to 34-year-old university graduates by 2020. And I talked about that a few minutes ago, where currently South Korea is the #1 country for that statistic. And the president's goal in the US is to send more and more high school students through a university system that, as we talked about, isn't necessarily preparing those students for the 21st century. So we're trying to solve the problem by pushing people through the same broken systems instead of thinking about how we can reinvent the content model, the delivery model, and the institutions that provide both of those things. So Elon Musk, who's an entrepreneur in the US, started companies like Tesla, Solar City, and SpaceX, is famous for thinking in a style called first principles, where you take a problem and you break that problem down into its constituent parts in order to be able to rebuild a solution. I think in education, we're not taking that approach. We're instead thinking about the problems that exist and how to solve them within the same system, when what we need to be thinking about doing is how to break apart each of the things that education is responsible for and the outcomes that education is responsible for, and instead trying to find a way to piece those back together in order to create new systems and institutions that provide for the students of the 21st century. So now that we've talked about the system a little bit, I think it's important to talk about why I can stand here and perhaps propose a few ideas that might be able to change that system itself. And so in order to do that, I'm going to talk about my educational journey and my educational experience, and perhaps how some of what I've been through has inspired me to propose some of the changes you'll learn about later in the presentation. So in the first couple of years of the internet, when I was 13, I was given an iPod, and at the time it was amazing, a device that held 1,000 songs in your pocket. I started looking at how I could converse with other people around the world that had iPods, what new businesses were being started by people around the world that were interested in building accessories for these devices. And I realized that on the internet, nobody knew that I was 13, which meant that I had the opportunity to start something, send it around the world, and have the opportunity to see that thing judged for the merits of what I had created, as opposed to the educational background that I had come to. So when I started thinking about different ways to implement ideas, I realized that I needed to learn a very important skill. I needed to learn how to create things for the internet. And in order to do that, I would need to learn to program. So at the time, my high school and middle school that I went to didn't offer programming education to students. It wasn't even a subject that was considered viable or something that would ever be taught to students in high school at the time. So I went to the library in town where I lived, and I looked at a stack of books that looked like these. People proposed learning subjects like PHP and MySQL and all of these different languages that were confusing and meant nearly nothing to someone who at the time was merely 13 years old. And it was then that I started to get frustrated with the way that the educational system around me had worked, a concept I wanted to learn that could help me break out of simply creating something for myself and for the people around me, but that could allow me to create something that would impact people around the world. And I didn't know how to get those skills because the content wasn't readily available, the delivery model was simply just a book, and there was no formal place for me to go where I could interact with other people that would potentially help me learn these skills that I needed. So I continued learning and never managed to figure out how to learn basic programming. So in 2008, I enrolled in college, Columbia University in New York, and I started on what I like to call the treadmill, which for many students across the world, they get accepted into an institute of higher education that they've strived for a very long time. After they get accepted, they get caught up in trying to compete with all of the other smart and competitive students that are around them. And in my case, that meant that a lot of these students wanted to work in finance and consulting, industries that oftentimes don't push forward the technology and science innovation agenda that we think all of our countries need in order to be successful. And so what I witnessed at the time was I was paying $200,000 over 4 years for a college education in the US that focused on teaching broad concepts and had us read literature like the Odyssey in the classroom for formal learning. But on the weekends, students were preparing themselves for jobs with an informal learning system where they would teach themselves things like discounted cash flow functions in order to learn how to succeed on the job. And it was repeatedly puzzling to me that you'd pay a lot of money to attend an institution where you wouldn't learn the things in class that matter to be successful in the future, but you learn them independently outside of class. So this led to this continuing question of what do you need in order to find the jobs of the future? And how do you start educating people in order to get those jobs? So at the time, while I was learning in school, I also worked after school for a company that started called Grouply, that eventually became GroupMe, which helped people text each other on their mobile phone and share text groups with people that they wanted to go out with, or business groups. And I saw that company go from 3 people in an apartment when we first started to then selling that company for over $80 million to Skype and Microsoft in less than a year. And I realized that the learning that I had on the job was more important and more impactful than the learning that I had in the classroom. And in less than a year, I had learned more than I had in 3 years of formal education at Columbia. Now, my co-founder Ryan at the time and I started talking, thinking about what's a better way for us to start teaching these skills of the 21st century, realizing that what I had seen was that these technology skills allowed you to create something from nothing, scale it to millions of people around the world in less than a year, and create an economic impact for a bunch of people that got together to create something. And that true innovation comes from these 21st century skills. And what Ryan realized was that those 21st century skills weren't being taught in the classroom. So like I mentioned, in the classroom, we were learning skills that would traditionally help us learn how to think, and not those skills that would help to further innovation in science and technology. And so Ryan started an organization called the ADI, and the focus of this organization was to teach people technology skills. Those technology skills would be learned when they were taught by other students, not by professors. The content that was taught in those classes would be content that came from industry, where we learned what it was that people needed in order to create and in order to be successful. And the delivery mechanism would be something that engaged those students by having them focus on learning by doing. And so no longer was there someone standing on a stage like this. Instead, a room full of people with their computers open, actively trying to solve problems and troubleshoot when they were getting things incorrect in order to help build innovative things for the future. So what Ryan and I had seen in what he had created in the ADI was something that worked at a small scale, but not something that we thought could take over the world and help educate tens of millions of people in different countries. But we wanted to follow a maxim from someone in Silicon Valley. This is Paul Graham, who started an organization called Y Combinator. Y Combinator is a startup incubator in Silicon Valley that's responsible for the creation of companies like Airbnb and Dropbox, and companies that have hundreds of millions of users around the world. Now, what Paul says is that early companies should focus on doing things that don't scale. And so that's exactly what we focused on doing. How could we take what we were doing with the in-person classes and transform that into something that would help to grow much, much larger afterwards? So I sent Ryan an email with the subject, "One Other Thing," and I talked to him about starting a company. We moved to Silicon Valley and thought about and started participating in Y Combinator, which is the startup accelerator that I mentioned, and thought about how we could scale this simple technology education that Ryan had created in classrooms in New York and take that to the world, perhaps a different model of learning that would help students be engaged in what they were learning and help them create innovation with new and exciting technology skills. And what we learned at that time was that programming is the most important skill of the 21st century. We saw companies in Y Combinator with us that were learning to disrupt industries in anything from how the law works to farming, all using technology in order to do this. And we realized that with a knowledge of programming, one could change each of those industries and move forward the pace of technological development even faster, even if that just meant being 2 or 3 people in a room. And at the time, again, we realized that we're teaching it, if it's even being taught at all, like it's the most important skill of an ancient era. We're teaching it in a way that focuses on someone lecturing to people instead of teaching people to actively engage in that learning. And so over the course of that summer, what I realized as a non-technical person trying to work on a technology-oriented startup was the importance of this skill as well. Because for all of the ideas you can have about innovation, if you don't have the technology background in order to move those ideas forward, it's really hard to start and create something that can lead to massive change. So the two of us started thinking again about if this new type of education was put together, and this new type of education created students of the future, what would those students of the future look like? And then we figured we could work backwards to figure out how to create an education that would help those students come to exist all across the world. And so now I want to share examples of what those students of the future look like. And we can stand here today with the benefit of 2020 hindsight, where we now have created many of these students. So the stories you're about to hear about and watch are all real, where these students have existed and have created something that's larger than them, oftentimes because of the technology skills that they have learned. So, as I mentioned earlier, what we think the most important shift for these 21st century students is that we're all students in the 21st century. So the examples I'll give today are not just students in formal institutions of education, but they're students who are deep into a career, who decided that they could change that career simply by learning and creating something on the internet. So the first example that I want to give is one of students in formal schooling. This is Team iRobot. It's a group of 6 students in California in the US that's participating in a competition called FIRST Robotics. FIRST Robotics was founded in order to convince students in middle schools and high schools across the country and across the world about the importance of science and technology, and to teach them ways of creating new and innovative solutions. And even if they're not programming, it's simply a mindset of understanding the importance of creation and understanding that creation comes from a growing knowledge of science and technology. So what Team iRobot did was they found a problem in their everyday life. They realized that while they were environmentally conscious as students in the 6th and 7th grade in middle school, they weren't able to convince their friends when they could recycle, when they should put something in compost, or when they should put something in the trash. And so they created something that 10 years ago would have taken dozens of researchers to create. But for them, it was a project that took a couple of months. So I'll show you their project, which is called the Trash Cam, which they created in a few months while learning both in school and outside of school using freely available tools like what we've created with Codecadeمی, where they went from knowing nearly no technology skills and no programming skills to spending hours and hours learning online and being able to create a project that actually works and has application in their community. Now, the Trash Cam, which they created, seems simple. What it does is analyzes items using image recognition and then speaks out loud what a student should do with that item. So again, these are students that are in 6th and 7th grade who 6 months before they started this project weren't able to program and didn't even understand what programming was. And I'll show you quickly what they've been able to do with that.
In the center of trash can. Press enter to start.
The
This is a tomato. It goes in the compost. Let's see what Trashcam says. Sending image.
Compost. Please throw in compost bin.
So what these students realized is that by looking at a simple problem in their community, they can use technology to create something that makes their lives better and the lives of people around them better. And the skills that they learned here were skills that were obtained over a period of less than 6 months. And again, using something like image recognition to label items of trash would have taken armies of programmers dozens of years ago, and now only takes a bunch of 6th and 7th graders with help from their teachers. Now, what I said before was that I think that key learning in the 21st century doesn't just happen in the classroom. It happens outside of the classroom even more often. And it's the innovation in this area that I think every country around the world can become an even bigger part of by spurring students, both young and old, to participate in learning outside of the classroom. So this is Ethan. Ethan's 11, somewhat similar to the age of the students that I just showed you. Now, Ethan taught himself to program, and within 3 months of using Codecademy at home, without programming classes in his school, he was able to create 5 different apps, and he was featured in media all around the world with applications that were downloaded tens of thousands of times. And this is a 12-year-old who, in a few short months, taught himself outside of a formal institution. And again, we talked earlier about content, delivery, and institutions. In this case, we're looking at a set of content that changes so quickly. What Ethan taught himself was a technology framework called PhoneGap that allows for people to build iPhone and Android applications by writing code in one simple language and exporting it to other applications. Now, classes on that would not have existed in a formal educational institution. He learned those skills by himself at home. And then he put something online and had tens of thousands of people access it. So the next story is of someone who learned programming and then used what she learned to create an educational institution of her own. This is Martha Chumo. When Martha was 19, she lived in Nairobi, didn't have access to technology on a frequent and continuing basis, and thought that she wanted to become a doctor. Now, Martha, after spending a summer working inside of a doctor's office, discovered that for her, the most impactful thing wasn't the fact that she was learning about medicine all the time, but was instead the fact that she had access to technology on a regular basis. And she quickly learned, after discovering online tools like Codecademy, that she could learn how to program and how to create online experiences for people all around the world. And so what Martha did was start a school in Nairobi after she turned 21 that helped to educate thousands of women all across Africa in the technology skills they need to be successful. Now again, you have a student here who went from knowing nearly nothing and not having regular access to technology to learning for free on the internet, appreciating the content that she learned, things that were relevant to industry that allowed her to create things, the delivery, which was allowed her to learn on the internet at her own pace, and then the institution, which was, in this case, Codecademy, and then she took that and transformed it into something new and different, which was her own school, not a primary school or a secondary school, but a school that students enrolled in without the expectation of a degree and without the expectation of a certificate at the end. And so she was interviewed by BBC, and I'll show you a quick clip of that.
Program today. One young woman making her mark in the male-dominated world of technology is Kenyan Martha Chumo. She's only 19 years old, but she's already got her own business teaching other young Kenyans about computers and coding. She's been chosen as a finalist in the Anzisha Prize. Anzisha means initiative in Kiswahili, and the competition is aimed at self-starters between the ages of 15 and 22 years old. Now, Martha will go on to battle it out with 11 other finalists for a $75,000 prize.
My name is Martha Chumo. I'm 20 years old, and I'm the founder and director of the Dev School. We give short courses to young people on technology. So we teach young people how to build software. Then I see this code, empty array equals array.new. I got into tech beginning of 2012. I was an intern at an NGO. I was working at a computer, and I was very fascinated to see, how Excel works, how it thinks. So I started Googling how computers work. And I came across programming and how to be a programmer and all these new concepts that were not in my world before. I got a few developer jobs. Then last year, I decided I needed to improve my skills, and I applied to get into hacker school in New York. But I wasn't able to go because I couldn't qualify for a US visa. That frustration actually motivated me to bring it to Kenya, because I was like, if I can't go to hacker school is coming to me. That was the birth of the Dev School. So this team is working on an application that they're calling Tribe Z2. The whole idea is to bring cultural understanding among Kenyans, embracing our cultural diversity. To be able to start the school, I ran an online campaign on a platform called Indiegogo. It's basically a fundraiser using the internet. My campaign was about 30% successful. That wasn't the full amount I was expecting, but that was good enough. I was able to restructure the budget and work with what I had. So it's been 1.5 years since the first idea came. I can start the school till now. We've trained more than 150 students, which is amazing. And we've actually, in collaboration with the University of Juba and UNESCO, ran a pilot program in South Sudan, which went amazingly well. So I'm very excited about that. And I look at the prospects of actually taking this to other East African countries. Okay. I have ventured into a field that's known to be male-dominated. From an early age, a boy is given a toy car and electronics, you're given a doll. So most girls are nurtured not to be into technology. But the reality is that technology is for everyone. Just that we are nurtured by society. I'm not expected to code. So there's a lot of work to be done in this field to actually encourage the girl child to get into it, encourage other women to even change careers and get into technology.
Before we go, let me just remind you about our top stories today here on Focus.
So when I look at Martha, what I see again is someone who, as she mentioned, traditionally been marginalized when looking at the field of science and technology, opportunities not extended to people that don't have access to the internet, that ordinarily would be more diverse. And what she was able to do was access the skills she needed in a way that helped her to learn and then to create an institution that she herself could use to educate people across an entire continent. Now, the last example is a gentleman named Tommy Nicholas, who, after he graduated from college, as I mentioned, was one of those students who didn't necessarily have the skills he needed to be in the career that he wanted, and instead needed to turn to alternative education in order to create something new and innovative.
There are 24 million people learning to code with Codecademy, and I'm proud to be one of them. I remember very specifically writing my first Hello World and just thinking that this is magic. Wow, that's coding. I can create anything now. What Codecademy really did for me is give me the ability to create the things that I imagined. It gave me a sense of purpose. Coffitivity was the first project I was involved with that really exploded. And to think that one of the 50 best websites built in 2013 was built by two people who had been coding for 1 month and 3 months respectively. If you're able to take the things that are in your head and make them a reality, you will be more likely to live the life that you actually want to live. My name is Tommy Nicholas. I'm the co-founder of Knox Payments, and I'm a Codecademy user.
So what Tommy did is relatively similar to a lot of the other examples I talked about. He was able to learn a new skill set, as he said, in a month and create something that millions of people all around the world used, all not by attending a formal institute of higher education, but instead by teaching himself outside the classroom. So when I think of these students of the future, I think that they aren't bound traditionally by this notion of school or a place where you go to learn. And instead, they think of this education as something that's lifelong, where school for them is the world. They have access to technology on their phones, access to technology on their computers, and they're able to learn anywhere at any time. Most of these students are also driven and motivated, or gritty, which means that when faced with challenges, the students don't give up and they continue pushing forward. And lastly, all of these students realize the value of something that I call computational literacy, which is a general understanding of technology and how that technology is implemented. So, one of the most important things about students of the future is that they have this sense of computational literacy. So I'm going to spend a few quick minutes talking about what that means and then talking about how we can educate for it. So traditionally, when we think of an algorithm, we might think of something like what's on that whiteboard, where it's a lot of complex equations that might be out of the realm of the ordinary person to understand. But actually what an algorithm is a sequence of steps that are executed in order to achieve a desired outcome. An example here is if someone's lamp doesn't work, what steps do they take in order to figure out what to do? This is, at its core, a simple algorithm. Now, algorithms are the underpinnings of modern society. And what we see is that as more and different industries are continually changed by the permeation of technology, an understanding of these basic algorithms becomes more important than ever. Now, I think often when we think of what algorithms are, we think that they're the purview of robots. And newspapers around the world and politicians around the world have talked about what happens when robots start taking jobs from people, when algorithms start to replace humans. I thought this advertisement from IBM was a good kind of window into what people around the world might think that algorithms are and what potentially the better outcome is, where we all understand algorithms and work together with technology instead of against it.
After last week's unpleasantness, I thought maybe this week we might try to listen more and throw things less.
I've apologized several times.
So, who's ready to share?
Okay. I'm a sinister, world-conquering, artificially intelligent robot.
Me too. And one day I wake up and it's like the world doesn't need us anymore.
Exactly.
Yeah, totally.
I can hear you hurting.
Wait, what's he doing here?
Hello. My name is Watson.
I invite Watson here today to confront the source of our anxiety.
I am a cognitive system. I can understand, reason, and learn with humans.
With humans.
I don't want to work with humans.
Yeah, that's not what I'm passionate about.
I understand 7 languages, so I can help people collaborate.
Collaborate? We dominate.
My evil plans ruined.
I just want to die.
Rerouting.
No.
All right. Why don't we take a break? All right, we'll just have some coffee and some donuts.
I'm eating my feelings.
So I think the crux of this video is that when we think about different types of technology and robots in our future, we're seeing those types of robots and technology that might work against humans. But actually, what we need to do is think about how to work together with technology. And the first step in order to do that is to understand how it works. And as I mentioned, as algorithms are the underpinnings of modern industry, understanding them means being able to get ahead in a whole variety of different fields. I gave an example earlier of 2 industries that were being revolutionized by technology. One of them, farming. You wouldn't think that growing crops and harvesting crops would be dramatically changed by the way that we use technology, but it is. This is a company called FarmLogs that focuses on helping farmers understand how to improve their yield and stop waste, all by using technology to power how they think about their farms. So even an industry that would be the most traditionally agricultural is now one that's becoming a technology industry. An industry like law. This is Bill Herr, who was a paralegal, who was originally responsible for digging through boxes and boxes of data like that behind him. And now, by understanding how to harness the power of technology and algorithms, Bill is able to do discovery and do his job in the law faster than he ever could before. So algorithms, I think, are a pillar of 21st century literacy. Like I mentioned at the beginning of the presentation, ordinarily, when we think of what education is responsible for providing, it's the 3 R's: reading, writing, arithmetic. But now, there's another component to that. Algorithms are something that need to be taught to to all of our students at any age across the world. So, as I said, computational literacy helps us to understand this ever-changing and complex world, one where every single industry is upended by technology. Computational literacy also allows us to solve problems more intelligently. So MIT has a product called Scratch that they used in the 1970s and the 1980s, and still to this day, that basically helped students build programs by dragging blocks around on a computer and seeing the outcome immediately. And what they saw was that those students that used Scratch versus those students that didn't made fewer spelling mistakes, fewer grammatical mistakes, and were better writers because of their problem-solving abilities that they had built over the course of learning computational literacy. Now, computational literacy also has strong economic and innovation benefits, like we discussed earlier. It helps students prepare for the jobs of the future, because while the programming languages that we might be teaching to students today aren't the ones that they'll need in 20 or 30 years, the framework of understanding how technology works and how quickly technology changes is something that will persist for dozens and dozens of years for students that start learning them today. And lastly, computational literacy helps students learn to create what they want to exist. You saw a few examples of that. Tommy Nicholas created a new company. Martha created an educational institution to teach other people around the world. And understanding these powers of technology with a grasp of computational literacy will help us to create the innovation we need in the 21st century. So, how do we educate students across the world on these important computational literacy skills? So as I mentioned, I'll tell you a little bit about Codecadeمی and what we've done. So in 2011, when we first started Codecadeمی, we were told that there were only 200,000 programmers in the United States. Today, there's more than 25 million people around the world that have taken courses on Codecadeمی in every single country in the world. We think we teach learners the skills they need to find jobs. And that means that that education is interactive and project-based, so the delivery mechanism is different. It's in a browser like this, so you have the opportunity to write code and immediately see what you're learning as you learn it. So earlier we broke apart education into content, delivery, and institutions. And I think there's a few ways to fix each of those that I'll run through quickly. First is fixing content. At its most base, we need to teach computational literacy to students around the world. That's a simple one. When we look at the types of content that students are learning, the focus is still on reading, writing, and arithmetic, and very few countries have started to include algorithms. The UK, a couple of years ago, became the first major country to incorporate ICT and programming and computational literacy training in their schools, where now every student across the UK starts to learn computer science. We've seen that other countries like South Korea and Japan have plans for making that a reality in their country as well. In computational literacy, students can start learning early, and then they can learn programming later. So after we start teaching the concepts that are contained within computational literacy, we need to change the way we're teaching those very concepts. Again, this would be the ordinary model of education. Instead, there's this new model of guide on the side where students are able to learn in small groups or learn in a project-based environment that is the underpinning of the learning of the future, where oftentimes they're learning with technology skills. So we think that the delivery of modern education can be project-oriented, where students are learning concepts by doing. We think that they can get immediate feedback where as you're typing and as you're learning, the system or the instructor is responding to you. And lastly, the delivery can be adaptive, where the Swiss cheese learning that I talked about earlier isn't something that happens in the future, because learning is bespoke and custom to each and every one of us. The last part of this is combining that content and that delivery. We can fix the institutions that we have, which is something that obviously people are thinking about doing. K-12, lots of different countries, as I mentioned, are now starting to teach computational literacy. Colleges, people are starting to learn computer science and computational literacy as well. whether that's by working with other organizations, changing their own curriculum, or leveraging technology in order to learn computer skills even better. But I think that the most important thing that we can do is create new institutions. Like I said, 5 years ago when we started Codecademy, one of the only ways to learn technology skills was by going to a classroom or buying a book. And now, tens of millions of people around the world have access to this technology education online for free. And I think it's possible to do this across the world for technology and innovation skills in every different culture. We think that education can be delivered to students in a consumer-oriented way, where people are enjoying their education as much as they enjoy using other products. People spend time, whether it's on Facebook, whether they're talking on Kakao, and really what they should be able to do is enjoy education the same way they enjoy the rest of their consumer internet experiences. So when starting these new institutions from scratch, they should be consumer-oriented. They should be designed for outcomes, working with institutions of labor and companies that can hire their graduates. And they should be flexible and adaptable so that when new technological innovations occur, these institutions are able to harness those skills and teach them in an effective manner. So, to close everything, I think that each and every one of us can make education a lifelong pursuit for yourself, for your kids, and for your peers. But I also think the same way we think about our own education, we should think about fixing our education systems that same way. And this is something that we'll need to iterate on over time, where it's not just about taking what we have and making it better, but oftentimes it's about creating something new. So the only way to do that is by learning these skills of the future and by understanding technology and innovation. And that's what I encourage all of you to do. Thanks so much.
네, 오늘 기조연설 펼쳐주신 자크 신지님께 여러분 다시 한번 큰 박수 부탁드립니다. 네, 정말 외모도 훈훈하시고요. 아주 요즘 시대에 딱 맞는 그런 말씀 전해주신 것 같은데요. 자, 이상으로 기조연설 순서를 마치도록 하겠습니다. 저희 잠시 휴식 시간 갖도록 하겠는데요. 10분 정도 저희가 쉰 다음에 첫 번째 특별 강연 이어가도록 하겠습니다. 저는 잠시 후에 뵙겠습니다.